And how we determine that? First we add 1 with the number of terms, then we divide that result by 2. That means here 2n plus 1 plus 1, and we take all these 2 together, then it will be 2 to the power n. The remaining factors will be 1 into 2 into 3 dot 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 n divided by 2 to the power n factorial n into factorial n, and this part 1 into 3 into 5 into dot dot dot, nth number will be 2n minus 1. Next sum, we have to find the middle term of the expansion of this one. I start. Let tr plus 1 will be independent of x. Now I find first tr plus 1 as per formula. Tr plus 1 is equal to, maintaining that formula, LCR a to the power n minus r into x to the power r. Here n is 10 CR into x to the power 10 minus r into minus 1 by x whole to the power r. That is equal to, I take minus 1 outside, minus 1 whole to the power r into 10 CR into x to the power 10 minus r, and here x is at the denominator, therefore it will be minus r. As it is independent of x, therefore this term will be 1, that means power is 0, x to the power 10 minus 2r is equal to x to the power 0. From that 10 minus 2r is equal to 0, therefore r equal to 5. We have to find the term independent of x, therefore required term is equal to, we put this value here, 10 C5 actually in this form, 10 C5 into minus 1 whole to the power 5, that means minus 1, the value minus 1, if its power is odd then value will be minus, therefore minus, now I simplify, factorial 10 factorial 5 into factorial 5, that is equal to minus 10 into 9 into 8 into 7 into 6. Try to follow the technique I am using. Factorial 10, there is factorial 5 at the denominator, therefore I write up to this and omit that factorial 5, then this will be 5 into 4 into 3 into 2. I simplify. You work out that 36 into 7 I suggest students you work out the rough work, calculation, etc. on the right space of the sum where you are working out. It will be minus 252. Therefore, required term is minus 252. That is the answer. Next sum, we have to find the middle term of the expansion of this one. For that, first we have to count how many terms are there in the expansion of this. 2n, that means even. Number of terms in the expansion of is 2n plus 1, which is odd. Therefore, middle term is, if it is odd, then there is one middle term. And how we determine that? First we add 1 with the number of terms, then we divide that result by 2. That means here 2n plus 1 plus 1 by 2th term. On simplification, it will be 2n plus 2 divided by 2, that is n plus 1th term. Therefore, middle term t n plus 1 is equal to, already we have got n plus 1th term is middle term. Now I apply formula. Here n is 2n, 2n c n into x to the power 2n minus n into 1 by 2x whole to the power n. I need space. First I will wrap this. It will be factorial 2n by factorial n into factorial n into the x to the power n into 1 by 2 to the power n into x to the power n. These two cancelled. Now we simplify this one. That is equal to I write in expanded form 1 into 2 into 3 into 4 into n, then n plus 1, n plus 2, to n, and this is factorial n into factorial n into 2 to the power n. Now I take all the numbers occupying even places, 2, 4 like this, 2, 4, 6, like this, into the numbers occupying odd places, that is 1 into 3 into 5 like this. Then 2 to the power n into factorial n into factorial n. Now, since there are n factors, totally 2n factors, out of those even numbers will be in n numbers, odd numbers will be in n numbers. I write here nth number, here also nth number. Then, and we take all these two together, then it will be 2 to the power n. The remaining factors will be 1 into 2 into 3 dot 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 n divided by 2 to the power n factorial n into factorial n, and this part 1 into 3 into 5 into dot dot dot, nth number will be 2n minus 1. Try to remember that the nth number of the series 1, 3, 5, etc. Let me make you understand. Nth number of 1, 3, 5, that is equal to a plus n minus 1 into d. You calculate that, you will get 2n minus 1. That is why I have written here the nth number, that is equal to 2n minus 1. Now product of these 1 into 2 into 3 dot 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 to n, that means factorial n, therefore 1 factorial n cancelled, 2 to the power n are also cancelled. Then what we get, 1 into 3 into 5 into 2n minus 1 divided by factorial n. That is the middle term. Finally, we write that Tn plus 1 is equal to this. This is the answer. Next sum. First I read the sum. Second and third terms in the expansion of x plus 3 whole to the power n are 240 and 720 respectively. Find x when n equal to 5. I have written the problem in short. Second term is 240, third term is 720 in the expansion of x plus 3 whole to the power n equal to 5. We have to find the value of x. Already given n equal to 5. Given expansion of x plus 3 whole to the power 5. Therefore, T2 5 C1 x to the power 5 minus 1 means 4 into 3, and T3 is equal to 5 C2 x cube into 3 square. Already given these two, therefore as per sum 5c1, I write 3 in front, x to the power 4 is equal to 240, call it 1, and 9 into 5c2 x cube is equal to 720, this is 2. Now I divide, as it is larger, I divide 2 by 1. Now 2 division 1, 9 into 5c2 into x cube by 3 5c1 into x to the power 4, that is equal to 720 by 240. We simplify. Calculate here, or 3 into factorial 5 by factorial 2 into factorial 3, then 5c1 means factorial 5 into, this will be taken into the numerator part, factorial 4, and at the denominator there will be x is equal to 3. Now we can divide both sides by 1, or x equal to, factorial 5s are cancelled, factorial 4 means 4 into factorial 3 divided by 2 into factorial 3 equal to 2. Therefore, x is equal to 2. Answer. Students, learners are to follow the steps which I follow to solve the sum. Second term as formula we have written, third term as formula we have written, then as per condition given we have framed two equations, and to get the value we have divided that and got the answer x equal to 2. Next sum, we have to show this expression is divisible by 100. Such type of sums we have got in the topic method of induction. Actually we can solve that with the help of method of induction. Also we can use binomial theorem. First of all, n equal to 2 or greater than 2. I solve like this. Given number equal to 11 to the power n minus 10 n minus 1. First we verify for n equal to 2. When n equal to 2, number is equal to 11 square minus 10 into 2 minus 1. 1 to 1 minus 20 minus 1, that is 100. Therefore, the number is divisible by 100. Now, if n greater than 2, of course integer, then what will be the process? Now, 11 to the power n minus 10n minus 1. I can write 11 as 1 plus 10 then 1 plus 10 whole to the power n minus 10 n minus 1. Now I write the expansion. 1 to the power n, that means 1 plus nc1 into 10 plus nc2 into 10 square plus dot 10 to the power n minus 10n minus 1. First, I have written the expansion of 1 plus 10 whole to the power n. Then on simplification it will be 1 nc1. If we simplify that, then it will be n, that is 10n plus nc2 10 square plus dot 10 to the power n minus 10n minus 1. We see these two are cancelled. Then n is greater than 2 integer, therefore all of these will be positive integer. I can take 10 square common factor, 10 square into nc2 plus nc3 plus also there will be a 10 into 10 plus nc3 10 square, nc3 it will be nc4 10 square like this plus dot last term will be 10 to the power n minus 2, as I have taken 10 square common factor. Now this expression is an integer, positive integer, which implies 100 is a factor. Since we mention here nc2 plus nc3 10 plus nc4 10 square plus dot plus 10 to the power n minus 2 is a positive integer. Therefore, the final comment will be, therefore, given number is divisible by 100. One thing, if this problem is to be solved with the help of binomial theorem, then we apply this method. And if it is not mentioned, that means no particular method is to be applied, then you can apply binomial theorem as well as method of induction. The sum is solved.